All right, 3.9 is called inverse trig functions. So we touched on this in algebra 2. So this some of it should seem a little bit familiar. We are getting more like into the actual graph of the inverse than we did in algebra 2. But we start with like, what is an inverse, okay? We're talking inverse of our trig functions. So the inverse of sine is sine -1 or arc cosine. You can use either one. The inverse of cosine is cosine -1 or arc cosine. The inverse of tangent is tangent -1 or arc tangent. What does that mean? It means we are switching. So normally if I ask you for the sine, I give you the angle and you're going to give me the y coordinate. And now it's the reverse. Remember any kind of inverse, we switch the x's and the y. So now it's going to say find the sine -1 and it's going to give you the y and you're looking for the angle. So the answers here are angles and they will be in radians because remember your whole test is in radians. So it says the inverse trig functions find a specific angle related to the given ratio. For example, because the tan at pi over 4 is 1, tan -1 of 1 is pi over 4. So this is what you're going to be looking for. What angle gives you a tangent of pi over 4? So if I remember, and we'll start just first quadrant, but if you remember first quadrant, you got your over 6, your over 4, and you're over 3, and then 0 and over 2. Hopefully we know our coordinate points. Root 3 over 2, 1/2. Root 2 over 2, root 2 over 2. 1/2 root 3 over 2 at the top, 0, 1. On the right, 1, 0. Then you want to know your tangent. So at 0, it's 0. At over 6, it's root 3 over 3. At over 4, it's 1. At over 3, it's over 3, it's root 3. And at over 2, it's undefined. So again, we're going to start first quadrant. If you know that, you literally have the bank of your answers. It can only ask you so many questions. So these examples will look like this. Notice it goes back and forth between sine -1 and like arc tan. Those arc and -1s mean the same thing. So number 1 says sine -1 of root 2 over 2. What's the answer to that? Pi over 4. Pi over 4 is where sine is root 2 over 2. Again, we're starting first quadrant. Cosine -1 of root 3 over 2. Pi over 6. Arc tan at 0. On the right? 0. At the top it's undefined. And then 0.25 would be 1/4. Is 1/4 a tangent from your unit circle? No, this is where you'd need your calculator. So you just do, make sure you're in radians, second, sine 0.25. You should get 0.253. 2526 rounds to 3. Okay, so let's talk about the inverse functions themselves and the graphs of them. Okay, so if you think about, we're going to go literally sine curve, we'll curve by curve. If you think about your sine curve, your traditional sine curve starts at 0, goes up to 1, back down to 0, down to -1, back up to 0. And I'd have a sine curve like this. If I keep going, it keeps going on forever and forever. Do you remember we had a test to see if something could have an inverse? Do you remember this? What did we use to test to see if a graph had an inverse? A horizontal line. If the horizontal line hits your graph at more than 1 point, it's not invertible. Do you remember that? So if I put a horizontal line through my traditional sine curve, is it invertible? No. So I have to restrict the domain. I have to restrict it so that a horizontal line would not pass through it as more than once. But I also have to restrict it so that it would cover both negative and positive values. So if I were to start here, so that I got positive and negative values, that's going to fail my horizontal line test, right? So I have to restrict it in a way that it would not fail my horizontal line test, but also give me positive and negatives. And that's why we restrict it here. It has to be a one solid chunk of your graph. Like I can't do a little bit here and a little bit here. That would pass my horizontal line test, but that is not a function anymore because we broke it up. So it would have to be something that is fluid, that has negative and positive values. So these coordinate points, here it's negative pi over 2, and here it's positive pi over 2. So we restrict the sine curve from negative pi over 2 to positive pi over 2 when we invert it. Which is why, and then if I inverted it, if I switched my x and my y coordinates, 0, 0 still stays 0, 0. Pi over 2, 1 would become 1 pi over 2. negative pi over, negative 1, negative pi over 2 would become negative, what did I just say? Negative pi over 2, negative 1, which would be that coordinate point, would become negative 1, negative pi over 2. And that's why the shape of the curve is like that. Notice my range is negative pi over 2 to positive pi over 2, which means the domain on the original one is negative pi over 2 to positive pi over 2. So when you are given an inverse sine question and it says negative whatever, negative root 2 over 2, negative root 3 over 2, negative, what did I miss? Negative, what did I miss? Root 2 over 2, root 3 over 2, negative 1/2, negative 1. Instead of going into the third quadrant, we go from the fourth up to the first, and we restrict it. I'll give you a visual of that in a minute. But that's why those answers can only have one answer. Now I'm going to do the same thing with cosine. My cosine curve starts at 0. No, starts at the amplitude, comes down, down, up, up. Looks like this. And again, it would continue on forever in both directions. So I have to restrict it. And I need it to be positive and negative. So I can't restrict it to the same thing we just did. If I do that, I get only positive values, and it would fail my horizontal line test. So we restrict cosine from 0 to pi. This would be pi over 2. This would be pi. And that's why this graph looks this way. At 0, 1, I would flip it, and I would get 1, 0. At 0, 0, I get 0, 0. I mean, at 1, 0, sorry. I get 0, 1. Not 1, pi over 2. At pi over 2, 0, I flip it, I get 0 pi over 2. And at pi, negative 1, I get negative 1 pi when I switch it. So the graph looks like this. You are going to be asked questions based on the graph and the transformation of that graph. So really, you have two options. Every time, take your points from that single curve and flip it, or memorize these curves, because it will be based on these three parent curves, okay? So sine goes up to the right, down to the left. Or cosine goes up to the left, down to the right. But it's above the x-axis, because again, we restrict that domain from 0 to pi, which means we restrict the inverse's range from 0 to pi. And then tangent has asymptotes at pi over 2. It has a curve that goes up to the right and down to the left. Tangent, just one single one would pass your vertical line or your horizontal line test, but I can't have more than one because then it fails. That was the worst squiggle at the end. It fails. So I only need one. I take one whole curve from the middle, which means I restrict my domain from negative pi over 2 to pi over 2, which means the range of your inverse is going to be negative pi over 2 to positive pi over 2. And if I take and plot all those points, negative pi over 4 would be at negative 1. So if I flip it, it's 1 negative 4. No, 1 pi over 4, negative pi over 4. 1 pi over 4. And then in the other direction, negative pi over 4 would be negative 1. Flip that, that's negative 1 and negative pi over 4. That's where this curve comes from. So your tangent curve is sideways, almost like a wave. So we need to know, 1, what the actual graph looks like. 2, how to restrict it when you're finding your inverse trig function. This is why when you go to your unit circle to find the answer for any of the first questions that we had, because we're going to see them in negatives in a second, you will restrict your domain on your unit circle. We said sine and tangent go negative pi over 2 to positive pi over 2. So we use the right side for sine and tangent. And notice you use the negative angles, negative pi over 2, negative pi over 4, negative pi over 6. You do not use your fourth quadrant angles. And cosine, we go from 0 to pi, and we use the natural angles in those quadrants. If you highlighted it, after you highlighted it, I would screenshot it because you're going to want it over and over again for homework. These are the restricted angles you're going to use for any of your inverse trig functions? Like these. So now they're negatives, right? It's going to be a blend moving forward of positive and negatives. If you know your unit circle well enough, I mean, obviously you can't have something like this on your test because you're not going to have something like that on your AP exam. But if you know it well enough, the goal would be to understand that curve without having to really draw it out. So where would the sine -1 be negative root 2 over 2? Now you can't use that angle. You have to use the negative one. Negative pi over 4. Where would cosine be negative root 3 over 2? 5 pi over 6, because cosine is in the top. Where is tangent -1? Can't use that quadrant. Negative pi over 4. Where is sine -1? Negative pi over 2. Can't use 3 pi over 2. That's wrong. Why? Because you can't jump. Okay, so now let's talk about our graphs. Just like every other graph we've done, all the parts affect these graphs the same way. The A causes a vertical dilation. If it's positive, it makes it stretch by a factor of whatever it is. Well, it stretches by a factor of whatever it is either way. But if it's bigger than 1, it's going to be stretched vertically taller. If it's less than, in between 0 and 1, it's going to be flattened from the top and the bottom. The B causes a horizontal dilation. This is by a factor of 1 over B. So this would be factor of A. This is factor of 1 over B. The C is a phase shift, and again, opposite direction as per usual. If it's positive, we go left. If it's negative, we go right. The D is a vertical shift up or down, positive up, negative down. Now you have to think about how that's going to affect your range and your domain. If it is A and D, these cause vertical changes. This will affect your range these will affect your range. If it's B and C, these are horizontal changes that will affect your domain. So we're going to think about what our original graphs look like, and then we're going to start to edit them. This says, describe the transformations on the graph of the inverse of sine or cosine, then find the domain and range of the inverse. Then graph the transformed graph. And it doesn't have to go in that order. We could graph it, then do the domain and range, but we're going to at least do both. Okay, so first of all, what's the 1/2 doing on cosine? It's a vertical dilation by a factor of 1/2. So vertical dilation, factor of 1/2. Is that going to affect my domain or my range? My range. We're going to get to that in a minute, but it's going to affect my range because that's the vertical, right? Okay, so if my original cosine curve, if you look back onto your cosine curve, we went from 0 to pi. At 0, it's 1, so we switch it. So my cosine curve looks like that when I invert it. Again, you can either memorize it or understand those 3 points and flip them. If you had to flip them, think about it. You're going cosine 0, 1, 1, 0. Correct, but we're flipping it. So these coordinate points, this is what my cosine curve would look like, right? It would go here, and then it would come back up again. So this coordinate point is 0, 1. This coordinate point is pi over 2, 0. This coordinate point is pi -1. Those are the only 3 we need because we're going to restrict it from 0 to pi. So when I switch it to plot my inverse, it's 1, 0, 0 pi over 2, and -1 pi. Oh, so did I switch this? All right, so now I plot my original, and now I need to perform the translations. So we said we are causing a vertical dilation by a factor of a half. So every y coordinate point there, we're going to cut in half. So this point that's at pi, divide by 2, it goes to pi over 2. This point that's at pi over 2, divide by 2, it goes to pi over 4. This point that's at 0 would stay at 0. And then my curve would just be flatter, squished. It doesn't have to be perfect. Like, obviously the left side I curve differently than the right side. It doesn't have to be perfect. But this would be my curve. Now, you can either use your graph to look at your domain and range, or you could think about the original domain and range from the inverse of cosine. My original domain for cosine is -1 to +1 for cosine -1. And my original range is 0 to pi. So if I looked at that without looking at my graph, we said the domain is going to stay the same. Nothing happened to my domain with a vertical dilation. But my range is getting cut in half. So both of these get cut in half. 0 stays 0, and pi goes to pi over 2. And then look at your graph. My x values went from -1 to 1, so domain stays the same. But my y values went from 0 to pi over 2, which matches the range. I would say the goal would be able to do that both ways. I think the graph is easier because it's visual, but there's going to be times in which you don't need to graph it. You need to understand domain and range, and then you can just cut it from there. But either works. You can either graph it. I mean, this question actually made you graph it, but sometimes it won't. You can either graph it and then figure it out from there, or you can use the original domain and range. Okay, let's look at B. Now we're dealing with the sine curve. What's the +1 inside the parentheses doing? Left 1. Is that going to affect your domain or your range? Domain. It's going to shift all my points to the left 1. How about the minus pi over 2? Down pi over 2. Is that going to affect your domain or range? Range. Okay, so this domain is going, you're going to subtract 1 from each of the coordinate points. The range, we're going to subtract pi over 2. Okay, so now let's plot our original. Think about your sine curve. Your sine curve is going from negative pi over 2 to positive pi over 2. It's 0 here. It goes up and it comes down here. So my curve looks like this. Those coordinate points are negative pi over 2 and -1, 0, 0, and pi over 2, 1. So if I flip them, I get -1, negative pi over 2. I get 0, 0, and I get 1 pi over 2. If you notice these graphs, the axes are reversed, right? Like on our vertical axis is our pi's over 2, I mean all of the ones with pi, right, all the radians. And on our x-axis is our regular traditional numbers. So -1, negative pi over 2, 0, 0, and 1 pi over 2. That's the parent function of the inverse of sine. Then I'm going to take those, I'm going to shift my coordinate points left 1. So left, left, left. And down pi over 2. Down, down, down. And this is my transformation. So let's do domain and range from the graph first. Domain, -2, 0. Those are the x values. Range, negative pi, 0. And then again, think about it if I didn't have the graph. If I just knew my original sine domain and range, the sine domain is negative pi over 2 to positive pi over 2. That's where we pick our points from when we do the inverse. And the range is -1 to 1. Yeah. So this would switch for the inverse. For the inverse, my domain would be negative 1 to 1, and my range would be negative pi over 2 to pi over 2. This would be the inverse domain and range. So then if I wanted to move left 1, I would subtract 1 from each of these, and I get negative 2, 0. And I would subtract pi over 2 from each of these, and I get negative 1, 0. So I think easier if you have the graph, but also know you may not have a graph to be able to read your domain and range. Question so far? Yeah. What do you mean? Oh, no. No. You mean like look for a phase shift and that kind of stuff? No. Yeah, no. Because they're different shaped and different domain restrictions. All right, now we go algebraically find the inverse of the function. If I gave you an equation and asked you to find the inverse, do you remember how to do it? Yep. 1, make f of x, y. 2, switch the x and the y. 3, solve for the new y. 4, change y back to f negative 1 of x. In this case, it will usually be theta, but this is how we do it algebraically. So make f of x, y, switch the x and the y, solve for the new y, and then change your y back to f negative 1 of x. And this is one of those things, remember f of x and y are interchangeable, but y and f negative 1 of x are not the same thing. You have to change that because you've changed the equation. Okay. So first of all, I would say don't worry too much about the domain restriction on your original one. It's good to understand it. But, oh wait, do you have just 3 over 2? Oh, no, that's right. It's good to understand it, but really what we're going to have to do is it's going to ask you to find the inverse, find the domain restriction on the inverse. So we're going to talk about that when we get to the end. So we're just going to start here first. First thing I'm going to do is change f of x to y. Now let's pretend tangent was like a square root or x, or that parentheses were squared. We can't get to this guy until we get rid of the tangent, and we can't get rid of the tangent until we get rid of anything that's on the outside of the tangent. So if there was a number added, I have to subtract it. If there's a number on the front, I have to divide. I have to get rid of all this stuff. Switch the y and the x. And now I want to solve for the y. So same thing still applies, right? I still can't touch that tangent y over 3 until I get rid of the 2. So I'm going to divide by 2. And again, that could be 1/2 x, or it could be x over 2. You could write it either way. Now x over 2 equals tangent of y over 3. If there was a number added to the end, I have to get rid of it first, but there's nothing there. In order to get here, I have to do the inverse of tangent, right? If I multiply, I divide. If I add, I subtract. The opposite of tangent is inverse tangent. So I tan negative 1 both sides. These are going to cancel. I get tan negative 1 of x over 2 equals y over 3. And then I want to isolate y, so I'm going to multiply by 3. I get y equals 3 tan negative 1 of x over 2, or f negative 1 of x equals 3 tan negative 1 of x over 2. Yep.
If you had a number doing a vertical shift, would you divide by the 2 with the tan first, or would you subtract the vertical shift?
I would subtract first and then move it. If you wait and subtract after, you would have had to divide by the 2 on both, so it would affect your vertical shift. Like you could do it that way, but it's more complicated. I would move the vertical shift first, and then I would divide or multiply, whatever, yeah. Okay, so now it's going to ask you to restrict your domain on these. So now let's think. What's the original domain restriction on a tan negative 1? That's the domain restriction on my parent function. right? My parent function, I restrict tangent from negative pi over 2 to positive pi over 2. And my range is all real numbers. So on my original domain, negative pi over 2 to positive pi over 2, range, all real numbers. So if I switch this now for my inverse function, tan negative 1, and this is on that first slide, the inverse function, the domain is all reals, and the range is negative pi over 2 to positive pi over 2. It will ask you only for the restriction on the domain. So that's all you're worried about. If it's all real numbers, there is nothing that's going to impact that, right? I could look at the x value here, which is going to be my horizontal dilation by a factor of 2, means I would double all those values. You double all real numbers, it's going to stay all real numbers. Now go to sine. So I think the easier part is obviously finding the inverse. Do that first. I'm going to switch it, and then I'm going to switch it and change the y in the same part. So this would be x equals 3 sine 2y. Yep. Okay, I'm going to solve for x. So I'm going to divide by 3. I'm going to solve for y, sorry. X over 3 equals sine 2y. I want to get the 2y out from the sine, so I have to sine negative 1 both sides. I'm just going to sine negative 1 the left. X over 3. It's going to cancel the sign on the right, 2y. And then divide by 2, which means multiply by a half. So f negative 1 of x equals 1/2 sine negative 1 of x over 3.
You can't leave it divided by 2.
You can't, like, it's not wrong, but on your, like, there's a question on this on your AP Classroom, and it's multiple choice. So you'll see it. It will be written as the 1/2. The other good news is, like, the AP Classroom domain, there's only one. So I don't think it's going to trick you. Like, I think there's only one right answer, but I'm going to teach you how to find domain anyways, just in case, okay? So now think about the restriction. So let's go back to sine, the original sine curve that we restrict. We go from negative pi over 2 to positive pi over 2. My curve looks like this. What's the domain? Well, actually, it doesn't even matter what the domain is because we're going to switch it to get the range. But let's say, what's the domain restriction here? Negative pi over 2 to positive pi over 2. What's the range restriction here? Negative 1 to positive 1. So on my inverse function, my range restriction is, my domain restriction is what? Negative 1 to 1. And my range restriction is negative pi over 2 to positive pi over 2. All we're really worried about here is the domain restriction. So if my domain on my parent function is if the domain restriction on my original inverse function is negative 1 to 1, I'm going to go to my equation. I'm going to say what part of this equation would be affected or would affect my x values or my domain. Does the 1/2 affect your x? No, that would be your y's. The x over 3 is affecting your x, right? What kind of dilation is that? Factor of 3. So I literally take 3 and I multiply it in. On the multiple choice, or on Classroom, it says negative 3 is less than or equal to x, which is less than or equal to 3. That's how it's written. Those obviously mean the same things.
Wait, so what is the,
So this is the restriction on your domain or on your x values. So when you see, you'll see on your AP Classroom, it's going to give you the equation, and then right next to it, it's going to say something like this, where x has to be in between those two values.
I thought the main was negative 5 over 2.
For your original function, the inverse would be the opposite.
Oh, so switch it right into
Yep. It's also like, I don't know, if you're like a memorizer, then go back to that first slide. Look at if you can memorize the shapes of these curves, right? And the domain and range, then you don't have to figure out your original and then flop them. But obviously that's a lot to memorize. So I would say if you understand the original shape and you can flip it, and the original domain and range and you can switch it, then you can understand what you're changing. For those kinds of questions where you're finding the inverse, you're only worried about the domain. But there are going to be questions in which it says graph and find whatever the new domain and range of your inverse. This is the restriction. This is the restriction on this sine curve. Oh, no, you didn't. Okay, there it goes. All right, so if you think about it, that's your original sine curve, right? Original sine curve. We said we restrict it from negative pi over 2 to positive pi over 2. That's our domain restriction on the original sine curve. Domain, negative pi over 2 to positive pi over 2. So if it's got a 2 in here, now we're saying that's a horizontal dilation by a factor of a half. So I would have multiplied each of these by a half, and now the domain restriction matches what they gave you. You don't have to worry about what they give you, though. They're going to give it to you. It's more, can you find it of what you have to find? So the original equation is restricting the original domain from your original sine curve. And the ending restriction is restricting the domain of your inverse sine curve.
So that restricts the domain.
Say again?
What's at the end restricts the domain.
Yeah, so it's in the question for you, and also on your multiple choice of the AP Classroom. They are all the same. It's not like they gave you 2 right answers with a different domain. They are all the same. Yeah. Question, my opinion, the easiest. We're back to triangles. If we want to do sine and cosine and tangent of triangles, what's the acronym you need to remember? SOHCAHTOA. So this says write A as a function of x. There's only 2 sides given to you and 1 angle, so we're going to set up a ratio. And then we're going to move it around, manipulate it so that it's x equals. So according to, in respect to the A, the tan is, the 10 is opposite. The x is adjacent, so I would say tan of A equals 10 over x. And I want it to just say A on the left-hand side. I want it to be solved for A. How do I get rid of tan? I tan negative 1. So A equals tan negative 1 of 10 over x. That's it. You just got to know how to set up your ratio and then solve for the other one. Amir. Sure. Yeah.
Wait, so like, is there ever a restriction that
It has 2 parts, right? We go innermost parentheses first. So I go here first. What's sine negative 1 of root 3 over 2? Pi over 3, right? The y, positive y, root 3 over 3 happens at pi over 3. So then I have to find the cosine at pi over 3. So you're doing 2 things. What's the cosine at pi over 3? 1/2. So it's not terrible, but it's a little bit confusing. If you have 2, you got to go inside first. Do inside first and then work your way outside. They're not all like that. Some of them are just pretty straightforward. We know how this one works, right? The circuit thing. So my advice is just go through it all and solve them all. See if your answer is at least an option so you know you're on the right track. And then go put the order in. Like, you don't have to go in that order. So like if this was 1/2, then that would lead to the question. It's on the second page. Okay, but make sure your answer is there. Make sure you don't get a duplicate answer. But then go through, solve them all, and then at the end, figure out your order. Because that's how I'll post the key. So this one said to graph the 2 periods of f of theta equals negative 2 tan pi of theta. So remember, when it's tangent, well, when it's anything, the first sign is going to flip it upside down. So instead of it pointing like that, up to the right and down to the left, it's going to switch. So it points up to the left, down to the right. The 2 is going to be where you mark your 1/4 point and your 3/4 point on the y-axis. So because it's upside down, we would go up to 2 on the left and down to negative 2 on the right. The pi is your b. So I use that to find 1. That means my period is changing. It's a horizontal dilation by a factor of 1 over pi. Okay, if you wanted to estimate what that would look like, it would be 1 over 3-ish, okay, is how much smaller it would be. So you would take your normal period and when you'd squish it by 1/3. But to find the actual amplitude, asymptotes and all that stuff, we're going to be more accurate. So I'm going to find the period, which would be pi over b, which is pi over pi. which means my period is 1. And then to find the, good morning, to find the asymptotes, we're going to set what's there inside the parentheses. So pi theta equal to pi over 2. And then I'd have to divide by pi, or multiply by 1 over pi. And I get theta equals 1/2. So yesterday we talked about that, like your asymptotes and your period, they don't have to have pi in them. They do a lot of times, but they don't have to. So if that's where my middle asymptote is, to the one on the right, I'm going to add the period, which is 1. To the one on the, to that one, I'm going to subtract the period, so I get the one on the left. So negative 1/2 and 1 and 1/2 are all 3 of your asymptotes. And then on the curve, I would plot them. So negative 1/2, positive 1/2, and 1 and 1/2, or 3 over 2. And then halfway between would be your intercept. If there was a vertical shift, we'd vertically shift it. Then we know the shape goes opposite, up on the left, down on the right, and that the A is 2. So I go up 2, I plot a point, down 2, plot a point, up 2, plot a point, down 2, plot a point. Any other questions from last night?